Today we're working on Module 7, Lesson 7. It is part 2 of our systems. So systems of equations, remember, are two or more equations. So we mostly concentrated on the perpendicular and parallel in the last lesson. So in this lesson, we're going to put it all together: perpendicular, parallel, and intersecting lines. So parallel lines, perpendicular lines where they cross at right angles, and they are intersecting lines too. And then there's just the basic where it doesn't cross at a right angle. I kind of made that look like it does cross at a right angle, but if I don't put a box there, then it's not a right angle. So those are the three types of lines. Oh, and then we had in the last section the coinciding lines. So where one line graphed right on top of the other one. So remember how this was no solution because there were no points in common. This was infinite solutions because every single point on that line is common to the two lines. And then each of these has one solution, whether they're perpendicular or just crossing lines. So this is one solution. And you write the solution as the point of intersection. This one is infinite solutions on the line. Infinite solutions on the line. And remember, this is no solution because they have no points in common, no intersection points, because that's what a solution is, the point they have in common, or the intersection point. So those are all the different scenarios we're going to talk about in this section, so it just puts them all together. These are the last 4 questions on your final exam, and I believe the last 4 questions on your Module 7 test too. I'm looking for this rubber band and I just found it in my blinds. Oh. Okay, so learning goal. Model contextual problems with systems of 2 linear equations. So that means we're going to move on to working word problems that have 2 linear equations. Solve using algebra, graphing, algebra techniques, which will be substitution and addition method, and then be able to write a full sentence about what that point of intersection means. So first we're going to learn about the graphing method. This is the least exact of the methods because, as you can guess, what if my solution's 2.37, 4.58? Am I going to be able to read that from a graph? No. So if they're nice whole number solutions, yeah, graphing's okay. But if the solutions are fractions or decimal, graphing isn't very exact. So it's the least popular, plus probably the most time consuming of all the methods. But we have to learn it because in the next class you may have, or maybe not the next class, but the class after that, you might have a circle and a line and you have to find the points of intersection, or a parabola and a circle, you have to find the points. So you do have to know how to do the graphing method for later, but substitution and addition method are used about 99% of the time. So, but we're going to learn all of them because that's part of our competencies. So we already know how to graph. We know that the y-intercept on this graph is 0, 3. So we plot the point 0, 3. And we know the rise over run is negative 1/2. Rise over run is negative 1 over positive 2. Remember, the denominator is always positive. So down 1 over 2, there's our line. Down 1 over 2. There we go. And then we would put arrows on both ends. Okay, the next line, the y-intercept is 0, negative 2. and its rise over run is 3 over 4. Okay, so go ahead and plot that one. Sorry, had to go run and do something. So 0, negative 2, rise 1, 2, 3, run 1, 2, 3, 4. Boom, there's our point of intersection right there. So the green line had that point and the yellow line had that point. So that is our point of intersection. And so how we find it is we go over 1, 2, 3, 4, and up 1. So my solution is 4, 1. So when the lines intersect at a single point, the point where they intersect is called the solution. It's the point of intersection or the point they have in common. And obviously when you're on a non-calculator graph, it's a lot easier to count those points. With the calculator graph, it's a little bit harder to get the coordinates. So the point of intersection is 4, 1. It's also called the solution, and that means the system is consistent. That's like the norm is having two lines that cross and they cross in one point. Remember how we said parallel lines were inconsistent because that's not the norm? So it's not the norm to never cross. That's why we call those inconsistent. Consistent means they have at least one solution, and here we have exactly one solution. Yes, we already did this. So to graph each, we start with the y-intercept, use the rise over run. Remember a negative slope. So this one had a negative slope. So notice the green line, excuse me, is falling. The second one had a positive slope, the yellow one, and notice that line is rising. So just a little reminder there. So negative slope means the line is falling. Positive slope, the line is rising. So both of those match our expectations. Negative slope, falling. Positive slope, rising. We could underline these with colors just so we know which one's which. Okay, so let's move on to page 2. So we're actually going to go through the whole process and then we'll start practicing some on our own. So I don't know if you remember from Module 6, but the first thing you have to do in order to graph a line is solve for y. So just like when I need to know the slope, if I need to know the slope and y-intercept to graph a line, which I do, I need to solve for y. So that should always pretty much be your first instinct every time you come to a problem that asks about parallel, perpendicular, asks you to graph, asks you for the slope, any of that, solve for y, because we've been doing a lot of that, right? So on this first one, to get y alone, we have to subtract 6x, and that leaves us with negative 3y equals negative 6x and minus 9. And then I want to show this next step out because there's lots of negatives there. So then our next step from here is to divide everything by negative 3. So that leaves us with positive 1y, positive 2x, and positive 3. So there is our line. So we can see our y-intercept is 0, 3. So we go to the graph and mark that 1, 2, 3. Put our arrows on both ends, what the graphing calculator doesn't do. And from that point, our rise over run, or our slope, is going to be 2 over 1. So rise 2, run 1. Rise 2, run 1. And there's how they got the yellow line. Okay, so let's go ahead and look at this one. So this one, in order to get y alone, we have to subtract 2x, and that leaves us with positive 2y equals negative 2x, negative 6. And notice how I never line these up underneath each other because I don't want to accidentally combine them together because they're not like terms. So negative 2x, negative 6. And then let's move it over here so we can see more clearly what's happening. On the next step, we divide everything by 2. And so we get y equals negative 1x minus 3. So a single negative, so they stay negative. 2 divided by 2 is 1, 6 divided by 2 is 3. And remember, we always want a fraction slope. So that's what we're going to be graphing. So our y-intercept is 0, negative 3. And because this was a whole number, negative 1, we put it over 1. So our rise over run is negative 1 over positive 1. Remember, we always run forward so we don't trip. So y-intercept 0, negative 3. And I think I should have picked a different color because these kind of match, don't they? And then down 1 over 1, there's a line. Down 1 over 1, there's another point. And there is our second line. So remember, we need to find the point of intersection. So we look where the two lines cross, and then we write the coordinates. So left 2 would be negative 2, and then down 1 would be negative 1. So this is our point of intersection, negative 2, negative 1. Remember, this is the solution. So I don't want you just to think of it as a point of intersection. This is the solution because we're solving a system. So the solution is negative 2, negative 1. And since it has at least one point of intersection, again, we call it consistent. So inconsistent is when it has 0 points of intersection, like parallel lines. Consistent means at least 1. So this is a solution. This is the type of system. So you can see these aren't exactly easy. Well, they're not hard. They're just a lot of work, especially when the lines aren't solved for y. But we'll get the hang of it and we'll start moving faster. So we're not going to have enough time to finish this one, but let's at least start it. So the minute we see solve by graphing, that means you need to get y alone. Solve for y. Make it look like y equals mx plus b. So that should be your very first thought whenever they ask for slope, parallel, perpendicular, or graphing. That's the form we use for all of those things. So let's do our two cases. So here's our first one. We need to solve for y, make it look like y equal mx plus b so that we can get ready to graph. Ooh, this one's nice. One stepper. I like it. So y equals negative 2x and positive 6. So we have y alone. Now we're ready to write its important information to get us ready for the graph. So its y-intercept is 0, because remember y-intercept, x is always 0, comma 6.